In the last video, we used binomials that looked like a plus b and a minus b. And I used the word conjugates, but perhaps I should remind you that that's what these are called. If you have the same binomial with a sign changed in the middle, those two binomials are called conjugates. Whoops, that's with an A. And why are these useful? Well, it's because if you take a plus b times a minus b, or in the reverse order, it doesn't matter, and you FOIL them out, you get a squared minus b squared. You'll have learned about that in algebra in terms of rationalizing denominators with square roots, but it's really useful also in trig because of all those Pythagorean identities with the squarings in them. All right, let's try another example. It's pretty clear to me that the complicated side in this one is the left-hand side, so I'm going to write that down and then put an equals. And then I'm like, oh, what can I do with this? I don't see any trig identities that will help, but fortunately I typically think of algebra first. And there's always something you can do when you are being asked to add two fractions. Namely, you can put in the LCD and do the addition. So that's what I'm going to do here. The LCD will be 1 plus cosine times sine. So I'm going to take, and notice I didn't do that on the first step over here. I just wrote it down exactly as it is. Now I'm going to do some algebra to it. Okay, here we go. So I have sine of x over 1 plus cosine of x, and I need that denominator to be 1 plus cosine times sine. So I'm going to multiply this first fraction by sine over sine. And then what about the second fraction? Let's see, that one is 1 plus cosine of x over sine of x. And what that denominator is missing is the 1 plus cosine. So this one I'm going to multiply by 1 plus cosine of x over 1 plus cosine of x. And notice I'm showing that step in my proof. Now let's start working on simplifying this. Okay, so the first fraction, if I multiply them, gives me sine squared of x over 1 plus cosine of x times sine of x. And I am not going to distribute the sine of x into the 1 plus cosine of x because I'm thinking that in a future step I may be able to cancel. Now, if I can't cancel and I need to, I'll eventually distribute the sine in, but oftentimes just leaving things factored is the most efficient thing to do. Okay, and then in the second spot, I've got 1 plus cosine of x times itself, so I'm just going to write 1 plus cosine of x squared. And down below, I have sine of x times 1 plus cosine of x. So now I have the same denominator on both fractions. That's great. I can combine them into 1 by simply adding the numerators. So on top, I'm going to have sine squared of x plus 1 plus cosine of x, the quantity squared. By the way, please don't just not write down the denominator because you're not doing anything with it. That's really confusing for your reader to have things disappear and reappear. All right, what can I do now? I don't see any canceling I can do. But on top, I have a binomial being squared. And since I can't think of anything else to do, oh, by the way, notice these do not cancel. Why do they not cancel? It's because of this plus sign right there. The 1 plus cosine of x on top is not a factor. The one below is, so theoretically it can be canceled, but we need a factor of 1 plus cosine of x on top. And that plus sign there means that the 1 plus cosine of x on top is not a factor, it's a term. So I can't cancel, but I can square out that cosine of x, or 1 plus cosine of x. So let's do that. Now I'll have sine squared of x plus, and here comes the squaring. And, oh, by the way, I am using the formula, I'm going to use the formula. A plus b, the quantity squared, is a squared plus 2ab plus b squared. I'll put that off to the side so it doesn't get mixed up with our proof. But I'll keep this part in green to help you see what's going on. So I'm going to have 1 squared, which is 1, plus 2 times 1 times cosine, so that's 2 times cosine, plus cosine squared, so that's cosine squared of x. And then down below, I still have the denominator that I haven't done anything with. But I need to write it down anyway. Now what? I'm going to work on simplifying, but I don't see anything that algebra is going to help me with for simplifying. But I do see a spot where I can use a trig identity because I have sine squared plus cosine squared. And we know sine squared plus cosine squared is a 1. And then I still have this other one. Okay, so what's going on here? These ones are the same. Okay, the first one is the sine squared plus cosine squared. And then I've got plus 2 cosine of x. I haven't done anything with that. So at this point, on top I have 1 plus 1 plus 2 cosine of x. Down below I have 1 plus cosine of x times sine of x. And there's some obvious simplifying I can do on top. 1 plus 1 is 2, so 2 plus 2 sine of x, 2 cosine of x over 1 plus cosine of x times the sine of x. At this point, I'm not seeing any trig identities that will help me, so I'm going to keep thinking about algebra. Is there anything I can do to simplify? At the moment, no. However, on top I see I can factor. So let's factor a 2 out on top. The motivation for factoring in this situation is in hopes that you'll have factors above and below that you can cancel, and yes, bingo! The 1 plus cosine x's will cancel. This leaves me 2 over the sine of x. I certainly don't see anything I can do from there, so let's look back, because maybe that's the answer I'm looking for. Oh, no. What I actually want is 2 cosecant, but that's okay because 1 over the sine is in fact the cosecant, and I'm done.